So what is friction? Friction is a force that usually works against you. If you want to move something, you want to move a box across a floor, the surfaces, the two surfaces that come in contact with each other, the floor surface and the surface of the box, they kind of interact with each other and they tend to produce a force that resists the motion. So for example, if I have, let's say this is my floor here, and let's say it's a wooden floor and I have a heavy crate that's just resting on the floor, and I try and I attempt to apply some force to it. So let's say I put some force here, force to try and move the box to the right. The box will tend to want to resist that motion, and it applies a force back at me. Let's do it in a different color. How about red? The box will attempt to apply a force back against me, and we call that the force of friction. So I'll put little f there for friction. I'm going to designate friction as the red force over here. And what happens is that the two surfaces, friction is the result of many complex variables and many complex things happening, but basically the two surfaces involved are having all kinds of electrical interactions, and there might be surface aberrations at the microscopic type of level. Suffice it to say that there's a number of things affecting this motion and causing friction. For our purposes, we're going to know that it's a force that resists the motion, and it's a force, therefore, that's always going to be opposite to the direction that motion wants to go. So let's say, going back to our example over here, let's say we have a box here, and well, let's make it 10 kilograms. 10 kilogram box, it's not too heavy. And let's say we have two surfaces here. This is, let's say the box is metal and the floor is wood, all right? So we want to get this box moving, we apply a force. So what's going to happen? Let's do this in steps. You can have the box over here. I'm going to apply a force here. Let's say I apply a force of 1 Newton. All right, the box may not move. It may not move because friction will exert a force back at me of 1 Newton. And we call this force static friction. Static friction if the box or the crate is not moving. In other words, if I just put a little bit of pressure, a little bit of force on the box, it probably won't move it because friction will supply an equal and opposite force to the force I'm applying to keep it from moving. So here we have a friction force of 1 Newton, and here's the force I'm applying of 1 Newton. So let's look at this next step. Now, and I'm not drawing it too accurately, but let's say I increase to 2 newtons. Well, friction might decide to respond back against me with a force of 2 newtons. And we call this static friction because the box does not move. The box isn't moving yet, the crate's not in motion. So friction that's opposing the motion is opposing me with an equal and opposite force here. But then, over here, I apply a force of 3 newtons and something happens. The box starts to move. And just as it starts to move, friction resists me at 3 newtons, and then it gives way, and now the box starts to go. So now the box starts to finally move. And now that we're in motion, what happens is this. Now we're in motion. I'm applying a force of 3 newtons, and friction is still there, resisting me. But now that the box is moving, friction dropped down. So let's say friction drops down to maybe 2.6, let's say. I don't, just for example, 2.6 newtons. And we call this kinetic. Because kinetic for moving, motion, kinetic friction. All right? So it's moving, it's in motion, it's moving this way. And notice that the force of kinetic friction here is less than the maximum force of static friction up here of 3 newtons. So let's take a look at what happened if we draw this in a little diagram here. So here's the force that I'm applying, and here is the force of friction. So I applied a force of 1 newton, friction applied a force back of 1 newton. I applied a force of 2 newtons, friction applied a force back of 2 newtons. So far, there's no motion. So the friction we're talking about here is static or still friction. Then I applied 3 newtons, friction applied 3 newtons back, but this was the maximum force of static friction. The maximum force of static friction that the box was able to supply against my motion was 3 newtons. It was the maximum force before the box started moving. And then what happened was this force of friction dropped down to some smaller value, and I kept going with 3 newtons because that's when the box started moving. Now if I applied a force of 10 newtons, the force of friction will still be 2.7. If I apply a force of 500 newtons, the force of friction against that would be 2.7. So we call this number here the force of friction kinetic, or the force of kinetic friction. So this is kinetic right here, kinetic friction. All right, I'm going to stop with the video here now, and in the next video on friction, we're going to pick up here, and I'm going to try and explain it a little bit better so that we understand it a little bit more clearly.